Okay, hello everybody. Thank you so much for coming to today's webinar with Dr. Nitish Surathu, titled Fail-Safe Printing, Say Goodbye to User Error. We're very thankful for Dr. Nitish to be here with us. I have heard the presentation just before to check everything, and it's very interesting, it's very concise, and it's very powerful. I think that most people will find it useful, not only for Ackuretta, but also if you are printing with any other machine, you will see that there is very good tips and very good insights. So first of all, my name is Xavier. I will be your host today. And it's my pleasure here to introduce our guest speaker for today, as I mentioned, Dr. Nitish. Dr. Surathu is calling today from India. However, he has been practicing in New Zealand for the past decades. As a periodontist, Dr. Surathu is also accredited Associate Fellow of the American Academy of Implant Dentistry and a Fellow of Diplomate of the International Congress of Oral Implantologists. He has lectured around the world on periodontics and dental implants and continues to be actively involved with podium lecture, hands-on, and clinical courses. So Dr. Surathu further served for over a decade on the Executive Council of the Asian Pacific Society of Periodontology and is currently a director with the ACE Institute. His expertise really lies on all matters digital, and he's actively involved in the evaluation of new generation digital technologies in intraoral scanning, CAD software for dentistry, CAM milling technologies, 3D printing, guided implant surgery, and relevant materials. So as you can see, he has a lot of experience. I think it's fair to say that Dr. Surathu might be one of the most knowledgeable speakers that we could have asked. For that, I'm thrilled to say that he's been using Ackuretta system for over a year now. We really appreciate you being here today and making the time for us and for all the audience to learn from you. So just a quick note for everybody, we will be talking a brief outline of what we will be talking about today. So Dr. Nitish will talk about the factors that affect printing failures, including machine ones, resin, and accessory issues. He will also help you understand the relationship between these factors, and those are crucial. This relationship is crucial for troubleshooting failures because sometimes it's not only one thing, but how it relates with everything. We hope that this lecture can provide you with some clarity on what are the things to look for when printing, and it is full of experiences and details that will help you with your 3D printing journey. Now, last but not least, stay tuned until the end of the webinar, as we will be announcing a winner of a 1-year Alpha AI premium license, which is valued at $220 US. So stick around to the end. We will pick one of the winners from all the attendees today. If you have any question, you can type it on the message box down below on your bottom right, and we will answer all these questions at the end of the webinar with Dr. Nitish or with our technical team. So thank you so much, Dr. Surathu, for taking the time again to make this happen. And I hand it over to you. Thank you so much.
Thanks, Xavier. I'm just going to share my screen so we get this off the ground. Is my screen showing up, Xavier? Because it doesn't say share screen. Oh, yeah. Okay. And how do I put that in projection mode? Can you see my screen now?
Yes, we can see the screen, but it's the PPT. It's not the presentation. There we go. Now it is.
Wonderful.
Wonderful.
Let's get started. First of all, thank you for so many people from across the APAC region logging in for this presentation. I see some friends from New Zealand where I'm sure it's quite late, and friends from India as well. So there's a wide time zone here, and we've got a few people from Asia as well, I see. So very cool. Right. Not a very popular topic. And when we first talked about potentially doing a webinar on this topic, both I and Ackuretta were a little unsure because it's almost as if it's got a negative connotation to it. But then, hey, I think it takes some gumption to admit that failures do occur. I've had failures. I've been 3D printing for 5 years now, and I've had plenty of failures over the last 5 years. Obviously, I have less failures now than I did 5 years ago when I started out with a printer. But the fact remains that I do have the odd failure now and then. In fact, I saw one yesterday. And so failures occur for a whole bunch of reasons. And sometimes even I struggle to understand why a certain failure has occurred. I'm not going to pretend that I managed to figure out the cause every single time. Sometimes I just repeat a print and it works the second time, and I can't figure out why it failed the first time and it was fine the second. But in most cases, failure is something that you can actually sit down and analyze and understand. And if you do, you are going to enrich your understanding of 3D printing. You are going to get better and better at preventing failures. The other concern I had with this presentation was the fact that I didn't want to get too technical about it. There's a lot of you out there who are not as obsessed with 3D printing as I am. You don't want to get into the nitty-gritty technical details, and I understand that. So I've tried hard to keep the technical load on this presentation low to moderate, if you like, just enough for you to understand why failures occur. Also, it would be, I'm not somebody who likes to talk about problems until I talk about solutions. I hate people who bring me problems without any kind of idea for what the solution can be. I say that to my staff in my practice all the time. And so I am going to talk about solutions. And so it's not all about failures. It's about understanding 3D printing better. It's about understanding what can get you less failures or no failures. And it's about understanding what solutions you need to implement. After printing for 5 years, what have I learned? I've learned that failures do happen. I just admitted that. And I did say a little bit about the fact that I struggle to understand my own failures sometimes, because printing failures can be multifactorial. There are so many influences on a successful 3D print, ranging from resin nuances to temperature to quality of the orientation of the print in the slicing software. All kinds of things affect the success of a 3D print. And therefore, it's a very multifactorial affair, and it's quite difficult sometimes, unless you actually sit down and analyze every factor. It becomes quite difficult sometimes to put your finger down on any one thing and say, that's what caused this particular failure. I cannot therefore address every possible cause within the ambit of this presentation, and I'm going to steer clear of that responsibility. I'm going to talk about the most common failures. I'm going to talk about the most common causes and the most common solutions, and we'll keep it simple and light. But I'm going to try and give you a systematic understanding of 3D printing, because I believe that if you don't understand how 3D printing works, you're never going to understand how to prevent a failure. So again, there I'm going to try to keep the technical load a little bit low. If you gain a systematic understanding of 3D printing, then you will be able to work through a systematic sequence when prints fail. If you're not systematic about analyzing why a failure occurred, then you can get all kinds of random opinions about why it occurred. I mean, for most people, the easiest thing seems to be to take a picture and pop it on a Facebook forum somewhere and give somebody else the responsibility of coming up with the reason for your print's failure. And anybody who's done that knows that you get a zillion responses with a zillion opinions, and sometimes nobody seems to have any idea about what exactly happened in your situation. The truth of the matter is, nobody knows your own situation as well as you do. And if you actually approach things with a systematic sequence, then you can analyze what happened and you can figure out how to prevent that failure the next time around. So let's try and get that sorted today. Let's try and gain that basic understanding. I want to start with some basic printing fundamentals. I want to quickly say that if you don't get these things right, these are the most common reasons why prints fail. So it's very important to make sure that you're printing under the right conditions, that you're printing with the right materials, that you're using validated workflows, that you're using all the right components in your workflow in terms of everything that comes to be. And so it's very important that you create the right setup, the workspace in your own in-practice lab or elsewhere if you actually run a lab yourself. But let's start with looking at some of these factors. Printers don't like cold temperatures. Printers don't also like very hot temperatures. And while I live in a part of the world that seems to have a very nice temperature range, I'm well aware that that's not the situation everywhere in the world. Printers like to live in a room that is temperature controlled, and printers like to live in a room where the humidity is low. So a dry room somewhere between 20 to 25 degrees is a great place for your printer to be. Anything colder than that, and it starts to present some challenges for some materials in particular. And so if you're going in anywhere below 18 degrees, forget it. You're not going to get many successful prints at all. In fact, if you go below 20 degrees, you're probably going to see some failures, in my opinion. A lot of companies will say 18 to 25 degrees is okay, but I really would prefer that range to be somewhere between 20 and 25. Resin temperature is important. It's not all about where your printer lives. It's also about where you store your resins. I've seen practices where resins are kept in the path of direct sunlight in a lab or something like that, and it tends to heat up the bottle. The light doesn't necessarily get through an opaque bottle and cure the resin, but it doesn't help to have a very hot bottle as well. And so at the same time, you could store your resin in a very cold, dark place, and the temperature of your resin could be well below 20 degrees. And that's not great as well. And so it's a good idea to keep your printer and your resins in a nice place so that the temperatures are all ambient as far as printing goes. And so that's the first thing to get right. The second thing to get right is to make sure you mix your resins. And that doesn't mean you give your bottles a violent shake, because the minute you do that, all you're doing is you're creating bubbles in the liquid. So be gentle when you mix resins. Tip the bottle upside down, closed obviously, and then turn it back on the right side and all that kind of thing. But make sure you do it gently, make sure you do it slowly. Take care even when you pour a resin into a vat, for that matter. Don't create too many bubbles. Allow resin as well in a vat to settle before you start printing as well. All of these things matter. Check your build platform. I can't tell you the number of times I've seen printers with loose build platform screws. So in the image there, the big knob that you see right on top is your build platform screw. You want to make sure that that's absolutely tight and that your build platform has no wobble, and that in itself can set up a failure. In fact, it can cause serious problems for your printer as well sometimes. Make sure your vat is in position. Ackuretta has a great vat positioning system. There are depressions on the vat tray, and they sort of guide your vat into position. There's also two nice clips that clip the vat into into position with a cover. All of that is very nice, but it's still possible to get your VAT wrong, and it's certainly possible to get your VAT wrong in other kinds of printers that don't have these kind of positioning devices. Make sure as well that you've selected the right resin profile. That will show up even on your printer screen when you're about to start printing. I have personally selected the wrong resin profile, thinking that I'm going ahead with something else. And so that can so easily happen to somebody, and you don't realize you've sliced up the print for a completely different resin profile, whereas in reality, you're printing in a completely different resin. So that's something to get right as well. Make sure you've got enough resin in the vat. Now, a print failure can certainly happen if you have too little resin in the vat, but something far worse can happen if you have too much resin in the vat. So don't go past that max mark and have resin spill over out of your vat, outside the vat. That's certainly something you don't want to do. And make sure as well that your printer has up-to-date firmware. Ackuretta keeps updating stuff. So make sure you've got the latest firmware. Make sure you've got the latest slicing software. Alpha AI Premium is now up to 5.0.3. Make sure you've got the latest with the software. Sometimes softwares, when they have updates, they can have glitches. That's not too often though, because companies do test their software updates. If you want to wait a bit before you update, that's fine. That's your prerogative. But usually I like to keep firmware and software absolutely up to date. As I said at the beginning of the presentation, I am going to go through a systematic sequence. And my sequence is really going to be based on how parts appear on a printer in a vertical order from top to bottom. And so I've got a printer on the right side, and the printer has the build platform right at the top. The build platform has a print that the printer has just finished. If you look carefully, you can see the supports. You can see the actual print itself, which happens to be a surgical guide. You can see the vat or the container or whatever it is you want to call that. At the bottom, which is a bit of a container for the resin itself. There's a transparent surgical guide resin in that vat. At the bottom of that vat, there is a film, a transparent film. And while you can see film through a transparent resin like surgical guide resin or splint resin, there are plenty of opaque resins that have pigments in them that will prevent you from seeing the actual film itself. But if you cleared out all the resin in a vat, you would be able to see a thin plastic film at the bottom of the vat. That film's designed to be absolutely clear, designed to be absolutely intact, meaning it shouldn't have any punctures, it shouldn't have any scratches, and it's designed to be able to let light through from the light source that lies underneath the film and is usually in the bottom part of the printer. Now, Ackuretta has multiple types of build platforms. Going back to the top again, what you see there is the large build platform, but we'll talk a little later about medium platforms and small platforms. And of course, we have supports with Ackuretta. All that is automatically generated in the AI Premium software that you saw a video of just before this presentation started. And obviously, the vat in the case of Ackuretta is not some plastic flimsy container. It's made of solid cast metal. It's designed to last for a very long time. We, for example, have multiple vats because we don't like changing resins between vats too often. And so that's something I'd encourage you to do. Consider getting more vats. And of course, we have multiple types of resin. Right at the bottom, Ackuretta has a light source that we'll talk a little bit more about. It's made of 54 matrix LEDs, and they're controlled as well very carefully. So again, from top to bottom, this is the sequence that we will follow when we analyze our failures as well. But let's talk a little bit about printing axis. And there's three different axes, of course. There's the XY axis, which you see on the screen. And the XY consists of the length and breadth of that screen, whereas the Z is more reflective of height or depth. So let's try and understand this a little bit. The XY resolution of any print is controlled by the printer. The printer decides what that resolution should be. The Z, however, is entirely in the hands of the user. Now, What can the user do with the z-axis? Well, the z-axis defines the height of the print. So for example, you could be printing something like a single crown, and obviously that doesn't have too much of a height in terms of a z-axis. Or you could be printing an entire maxilla and mandible, for example, half a skull maybe, and that would have a substantial z-axis therefore. And so you can control the height of the print. But what's important to understand is that the user gets to control more than the height of the print. The user actually gets to control what are called layers. And these layers are very, very important to understand to 3D printing. So what does a layer mean? Well, first of all, let's try and imagine a three-dimensional object that you are trying to print. Let's say it's a model like the one on the lower left screen. Now try and imagine if you can slice up that model into 50 micron slices. There would be hundreds of 50 micron slices that make up the height of that model that you see on the screen. And so each of those slices is called a layer. Essentially, how 3D printing works is the build platform comes down, right down to the bottom of the vat, and it separates from the bottom of the vat by a thickness that is equal to each layer. So if you've defined a layer thickness of 50 microns, the platform maintains a thickness of 50 microns away from the bottom of the vat. And so in essence, there is a 50 micron thick layer of resin that is still between the platform and the film that lies at the bottom of the vat. If a light is turned on, which it is at the bottom through an LED matrix, then you get a cure of that layer. That layer that you've just cured sticks to the build platform. The build platform then moves away from the film and it comes back again to maintain another 50 micron distance from the film of the vat. Of course, it's already printed 50 microns as the first layer. And now when it comes down for the second layer, the platform is 100 microns away from the bottom of the vat. In essence, therefore, the 100 microns is made up of a printed layer of 50 microns that's already done. And it's now made up of a new layer of uncured resin of another 50 microns that you're wanting to cure. So that's how 3D printing works. The platform comes down and goes up and comes back, and each time it encloses a layer of uncured resin that is approximately equal to whatever layer thickness you have defined. Now, if you look at this print, this is from the print screen of the Sol, and if you look carefully, we are using a resin to print something. And don't ask me why I'm using a Curo cast setting to print this particular surgical guide. I have reasons for that because I'm testing something, but it's still good enough for us to try and understand how layers actually cure. And so if you look at a number there, one where my arrow is pointing, this is layer number 7 of a total of 371 layers. And that consists of just the supports of the print. Much further into the print, when we are at layer number 105 of the 371 layers, notice that a layer of the print starts to appear. Now, how is it that this actually works? Well, the beauty lies in this little thing called an LCD screen that is at the bottom of your vat. This LCD screen comes in between your light source and the bottom of your vat. And what this LCD screen does is it throws up a mask that looks exactly like this black circular picture that you see there. It throws up a mask, and what the black areas of the mask do is that they obstruct the light from hitting the resin. Where you see white, though, in this mask, those are the areas where the LCD will let the light through. And so only what is in white will actually end up curing. Very smart. And this was how 3D printer was invented by Chuck Hull way back in the late 80s. And so you see this continual printing of layer upon layer upon layer that is, and each of these layers are piled up one after the other on top of each other, leading to what we call a 3D print. Quite correctly, this is called additive manufacturing. Now, in a classic printer like the Sol, you've got a build platform on the top, and that build platform is able to move on a channel, and that therefore is the Z-axis. The LCD mask, as I said, is right below the vat, and it forms an obstruction between the light source and the actual resin itself. So you do get a sort of basic idea for how it is that 3D printing actually works. Now, if you're really obsessed with this, you can get into it and understand that there are multiple ways of doing this. You can do this with digital light projection. You can do it with lasers and SLA printing. You can do it with all kinds of other technologies as well. But this is how the SOL works. And the SOL is an LCD LED printer. The first level of failure that can occur when you are printing occurs at the level of the build platform. Typically, what you see is that at the end of a print, the build platform has come up and there's absolutely nothing on the build platform. It's plain as, and you don't see anything stuck to the build platform at all. Typically, in a build platform failure, you will see a layer left behind in the vat that is usually the very first layer that was printed. So this picture was taken from the Ackuretta user group, and the user group is a great resource sometimes to learn from other people's failures and from the comments that some of the more experienced users leave behind on the forum. This user has chosen to try and remove the printed layer from the bottom of the vat. That is something you should never do, because you run a high risk of leaving behind particulate debris that can break off from that layer. If you have a layer like that, I will show you how at the end of this presentation you clean a vat, and that's the right way to do it, of course. If you're working with a transparent resin, sometimes it may be possible to do this, but even then I would discourage that, especially for a novice user. And so if you have a build platform failure, you'll get left behind with a layer of resin like that and a platform that has absolutely nothing on it. If, on the other hand, you have a situation where the build platform has absolutely nothing on it, but there is no layer of resin in the bottom of the vat either, then that is a different kind of failure. And we will talk about that failure in a moment. That is typically a Z-axis calibration issue. And we will talk about that in a moment, and we'll talk about how to fix that in a moment. But let's start with a classic build platform failure. In a classic build platform failure, the most common causes are that there wasn't enough light to cure the resin for whatever reason. Second, there was too high a peel force. Now, what do we mean by a peel force? Here's a new concept that I'm going to introduce. When you cure a layer of resin, the layer of resin tends to adhere to the film that is at the bottom of the vat. For that layer of resin to actually stick to the build platform and move away from the film of the vat is what we call a peel force. Now, if you have a nice platform and it's rough enough, then if the resin cures onto that rough platform, then the resin tends to adhere to the platform. If everything else in terms of settings is right, then the printer is capable of separating that layer from the film and then leaving that layer adherent to the platform of the printer. And so that's what we call a peel force. It's like a battle between the platform and the film, and it's continually happening for every single layer. If at any point the film manages to overwhelm the platform for whatever reason, you will get a failure. Now, that can be right at the beginning, where nothing sticks to the platform, or it can be between the layers as well, where you get what's called delamination and a separation of layers within one print, and that's possible as well. And that can be sometimes as the result of our too high a peel force as well. But we'll talk later in the presentation about how you can reduce peel force, how you can make smart choices with regard to what you're printing, and then make sure that every print is as successful as it can potentially be. Platform characteristics are important, meaning that a platform has to have the right physical characteristics for resin to actually stick to it. Now, this didn't happen with the first platforms that came out from Ackuretta in the early days, But certainly later on, Ackuretta started to redefine the quality of their platforms much more. And what you will see today with Ackuretta is you will get anodized platforms that are black in color, and all of these platforms will have what is called a hairline anodization, meaning that there is a micro rough surface on these platforms that encourages resin adherence. If you don't have one of these platforms, I highly recommend that you buy a new one. And so it's well worth getting these platforms. And they're available in 3 sizes. Now, these sizes are really application driven, and we'll talk about that later in the presentation. But these platforms are available as large, medium, and small platforms, and they have purpose. You do get companies talking about the fact that you get reduced size platforms nowadays, and that these platforms are faster. Quite frankly, Accurata launched smaller size platforms many months ago, and these platforms have been available for a while now, and they have driven high speed printing in a variety of applications with the Sol for quite some time now. We'll talk a little bit about why these platforms are faster, and that is driven by a third factor called displacement reduction. Really, this is based on Archimedes' principle, and it's really not hard to understand. If you have a small platform, it displaces less resin. If you have a large platform, it displaces a lot of resin when it sinks into the resin. Obviously, the platform needs to come down the printer and go into the resin in order to print. So a small platform, therefore, will displace less resin. A large platform, therefore, will displace more resin. But the fact is that every time a printing platform needs to move away from the film, it needs to allow the resin to come back to level 0 before it approaches the resin again. So if you've got large displacement from a large platform, then that means more resin has to come back to the horizontal level. If you have less displacement of the resin from a small platform, then the resin returns far quicker. Now, if the resin returns far quicker, then the platform can approach the resin again much faster. So obviously, if you're printing with smaller platforms, the platform can go in and out of the resin much faster than a large platform. And again, if you're printing really small things, for example, in the lower right corner, you see if you're printing something like single crowns or small bridges or gingival masks or castable crowns in a lab that are going to be cast into gold or whatever. All of those are really small applications, and it's very useful to print these with a small platform, and they print super fast. You could use, for example, a ceramic filled resin like packed dent rod in sculpture, and you could very definitely print a crown in under 20 minutes quite easily with the small platform, and that is high speed printing. And so we've had this technology with Sol for quite a while now, and we've definitely had ceramic filled resins as well for quite a while now. And it's very easy to do these with quick print rates. If you're printing a full arch, let's say you're printing a splint, or you're printing a surgical guide, or you're printing a denture, or even one model, all of those are very easily done with the medium platform. And that can print in something like 35 minutes to 40 minutes quite quickly. But if you do have a large platform, and if that's all you've got in your practice, then you can certainly print all of these things on a large platform. It just takes longer because a large platform displaces more resin, and I explained why that is the case. But let's talk about another kind of failure. So we talked about a build platform failure. We talked about choosing the right build platform as one way of enhancing the success with your prints. And we're going to talk about what happens with a build platform failure when you don't see anything on the platform and you don't see anything in the vat either. That typically happens because your Z-axis is out of gear. What do I mean when I say your Z-axis is out of gear? Let's watch this video, for instance. This platform is moving down this printer. It's descending into the resin, and that's what it's moved. The platform is essentially moving down the Z-axis. It is approaching the resin, and you see that it is sinking into the resin. Got a close up there of the platform going into the resin. And that's really how a platform moves down the Z-axis. And that's what I mean by Z-axis. The resin now is being displaced by the platform, and the platform is, the edges of the platform are being covered by the resin in the vat as it encloses a 50 or 100 micron layer or whatever it is in order to start additively manufacturing a 3D print. But let's assume you've had a failure in the past with this particular printer. And let's assume that you left behind some particular debris in the resin of the tank. Try and imagine what happens if this platform comes down on some debris. That debris gets in the way of the platform enclosing exactly a 50 micron thickness. When it does that, the Z axis of your printer is thrown out of gear because the printer thinks that where the debris is stopping the platform from descending any further is the limit of the Z axis. And that creates a really big problem. Now, you could also cause this if you have a loose knob on your platform and you haven't tightened it properly. You can have it also if your vat is incorrectly positioned. You can also have it if your reseller didn't put enough lubricant on your printer. In any case, if you've got a printer and you've been using it for 2 or 3 years, depending on what climate you are in, it is entirely possible that your Z-axis channel has lost lubrication or now has reduced lubrication. Don't try to do that yourself. It's something you need to call your reseller for, and it's something you need to get your reseller to do. But it is possible that your Z-axis has lost lubricant sometimes. In any case, if you have a Z-axis calibration issue, I know you see lots of ads from Ackuretta that say that the printer needs zero calibration, and that's completely true until you throw your Z-axis calibration out of gear yourself. If that happens, then you definitely need to get tech support's help. Don't try to align your Z-axis yourself. Don't try to calibrate the printer yourself. The Z-axis calibration is critical to the printer functioning properly, and that's really what you want to call into support to ask how to do. And they will guide you step by step, but it's not something I suggest that you do. But I did bring this in here because if you do see a situation where there's absolutely no print on the platform, no debris or no left behind layer in the vat, think about the possibility of a Z-axis calibration loss issue. And that is something you call into tech support about. Right, let's move on to our next slide. We've finished now with the build platform. Remember, I said we're going to approach things systematically. I've got them on the right side here of the slide. I've finished with the build platform. We're now going to talk about supports. These are what we call supports. If you're absolutely new to 3D printing and you've never seen supports before, a lot of 3D prints end up being supported by this meshwork of little sort of branches or whatever it is you want to call that. These are resin supports. They are created by the slicing software, and they are a means of ensuring that any 3D print is supported. If you print directly with the print itself on the platform, then there is too thick a layer or too wide an area that needs to be printed at one go as a layer. Now that creates a significantly high peel force because your platform needs to fight your film to get a massive area of cured resin off the film. And that becomes hard for the printer to do. Whereas if you have supports help you to actually define how much of a layer actually gets printed at one particular point in time. So if you've got a splint like this and you've got it angled at whatever degrees this particular splint is angled at, then to the horizontal, you can try and imagine what layers of this splint will be printed. First layer would be something in the molar region, and then after that is printed something in the premolars would print, and then slowly you would have smaller and smaller areas of layers of resin that actually need to peel away from the film, and supports enable that. Now, supports can have a number. You can have many supports. Their density matters depending on what you're printing, meaning per unit area, you have more supports. You can also have thick supports and thin supports in terms of strength. You can have interconnectivity between supports, and that's what we call structure. And finally, the supports contact the actual print at a contact point, and you can define that as well in software if you want to. It's not something I recommend you do, but if you know what you're doing, it is something that you can certainly play with. I played with the print yesterday to get a better print myself. So it's something I totally understand how to do, but it may not be something you want to do. But supports are critically important. Now, if supports are critically important, you can have support failures like this print, for example, that is a splint resin. You can see how the supports have detached from the main print itself. And this is possibly either due to, it can be due to multiple factors. It can be due to incorrect orientation of the print, resulting in too high a peel force. It can be because the contact point between the support and the print is not good enough, and therefore that part never really printed. It can have to do with light exposure. It can have to do with all kinds of possibilities. But most commonly, this has to do with incorrect orientation. It can also have to do with insufficient supports in number, size, structure, or strength, especially if you are manually defining supports and you don't know how to do that correctly. It can also be because the contact angle between these supports is not set to a wide enough radius, and that in fact can also cause a failed print. You can also have unsupported areas of a print. Sometimes some prints need what are called intersupports, which means within the print itself, there are supports that are needed to support certain areas. For example, if you're printing a denture with a very deep palate, for example, you may need intersupports in a situation like that. In any case, all of these support areas are extremely common, mainly if you're doing manual supports yourself. Your easiest solution is to get software to do it for you. But let's look at supports itself. On the upper left corner here, I have a splint angled on a medium platform at 45 degrees, and that works extremely well because splint resin needs very, very low peel force. And so if you angle it nicely, you get very little peel force because at any given time, a 45-degree angle print is only printing a very small area of the print in terms of a layer. It's mostly printing supports, and that works very nicely for resins like splints. Look at the denture in the top center, for example. That is a denture that is printing the not the intaglio surface, but the oral surface of that denture. And in this instance, you've got multiple supports because there's a very deep palate on that denture, and you need supports to go into every part of that print in order to ensure that no part of that print is unsupported. On the lower left, there's another denture. This needs less supports in terms of density because you are connecting those supports directly to the oral surface in a horizontal orientation. And that's usually quite easy for the printer to do. And therefore, you don't see as many supports in that particular position. If you look at the lower center, that's again multiple splints. You need to think carefully when you put multiple items on a platform as well, because if you're using a medium platform with one splint, like you are in the upper left corner, and you have a low peel force from that, if you print just one splint, even on a large platform, it may be slower, but the peel force remains the same. But the minute you start to print 3 splints or 4 splints, or you put multiple items on a platform, then you are going to magnify the amount of peel force that the platform is going to encounter as it separates from film. This is important to understand because a lot of users will think, all right, I'm getting failures. Let me put 4 of these and at least one of them will print. That really is an issue where you're going to compound the amount of peel force, and that is only going to produce a higher risk of failure. And it's therefore not something you should be doing. You're far better off using one print again, and that stands the lowest risk of failure. Even better if you use a smaller platform as well, that will help things even become faster. On the lower right, you see castable resin, CuroCast, ProCast, and those are for castable crowns on a small platform. Notice how few supports there are on that particular print. So if you look at the upper right corner, though, that's supportless printing, which is very fashionable against expert users. But notice very carefully that the print has what we call a drain hole. I don't really appreciate the location of that drain hole. If you're going to do drain holes, and if you're going to do supportless printing, and you're designing your models in a model-based app like Medit Model Builder, for instance, make sure that you have your drain holes contacting the platform itself, because the resin needs to come out of those drain holes. It's also very important to think about whether you're printing hollow models or whether you're printing solid models. If you're printing solid models, then you're using up a lot of resin. If you're printing models without drain holes, again, you're using up a lot of resin. If you do resin, if you do models with supports, you do use a bit of extra resin for the supports. But if you're a novice at printing and you're not an expert at setting up drain holes, you're not an expert at working with STL meshes and making sure that they are light and hollow and open or whatever, I would suggest you do only support-based printing and you don't get into supportless printing at all. It just makes things far, far easier, far, far more predictable. In any case, your best solution for supports is to work with software that has artificial intelligence to generate those supports. If you're not an expert and you don't know how to play with manual supports, I suggest you don't. And so if you work with AI Premium, for instance, and I hear we're giving away one of these licenses free at the end of this presentation. If you're working with AI Premium, for instance, AI Premium will automatically orient the print for you, will automatically generate the supports for you, automatically generate a base layer for you, and you're less likely to go wrong, at least from the perspective of supports, assuming, of course, that all other things remain equal in this situation. So I'd highly recommend that you work with AI-driven orientation, with AI-driven supports, and that's almost the most predictable way of getting supports right. Finally, you can have supports behave themselves, but you can have prints go wrong. And these are usually separations between layers of the actual print itself. Now, these can be because of light source issues. It can also be because your light is okay, but your film is too smudged on the bottom of your vat. Therefore, the film's not letting in enough light. You can have unsupported areas of a print, for example. If you did manual supports, it may be that you oriented a print poorly and that you got too wide an area of resin for each layer, and that resulted in an extremely high peel force. If you're printing models, you may not have set up drainage properly, and that could lead to pooling of the resin within the print itself. All of these are factors that can cause print failure. You can also have issues with your vat. You can have incorrect alignment of your vat. This here is a print failure where we had the print fail at a slightly later stage and the print remained in the vat, meaning that the film got the better of the platform midway through the print almost. And so it's more than just that first layer. Now, this issue can be due to multiple issues as well. It can be because of the vat not being aligned properly. That's very unlikely with Sol. It can be because you have a Z-axis calibration issue, because you didn't clean your printer properly after a failure. It can also be because there wasn't enough resin in the vat, and that's a possibility as well. But these are things that you can think of if you have a failure with the vat. Some resins are harder to print with, and these are typically resins that contain things like glycols, or usually they're high molecular weight oligomers, and these are typical of surgical guide resins, splint resins. These resins are quite heavy as well, quite viscous as well. They're also transparent, which means that the printer struggles for light precision. The light passes through every layer, and it's very hard for the printer to kind of contain the energy down to a certain layer thickness in order to ensure that good curing occurs. So you do get these issues as well with transparent resins. It can also be because you selected the wrong, incorrect resin profile. You select these profiles, of course, when you actually slice your print, and you can select the absolutely wrong resin profile and then end up with a failure as well. Now, these resins also need mixing. And if you put them into a vat without mixing them, especially if they have fillers sometimes, and that can be a problem as well. So if you have fillers, the fillers can stay suspended at the bottom of the bottle, and if you haven't mixed the bottle properly, it's sometimes a situation where you don't pour out a consistent resin mixture. Watch out for that as well. It may be that your printer is in the wrong environment and the general temperature of the environment is not conducive to 3D printing itself. And you will find that more often than not, it's these kind of resins that fail when temperatures are not perfect as well. So that's something to take into consideration. Again, resin nuances are well taken care of by AI software. As long as you select the right profile, everything that Alpha Premium will do, Alpha AI Premium will do for you with regard to orientation, with regard to supports, and with regard to selecting the right layer thicknesses that are possible for that particular resin, the software will do all of that. So for example, here we are printing with Curo Splint, if you can see clearly enough on that picture. And it does give you 3 different layer thicknesses that you could potentially choose. And so the orientation also is perfectly controlled by the software, and the supports are also perfectly controlled by the software. So select the right resin profile and let the software do the rest for you. Let's talk a bit about film. Film, as I said, is at the bottom of the vat. And every time the platform comes down on the film and it tries to pick up a layer that it has printed, it encounters a peel force. And so if you have FEP films, then you can see that those films flex much more and they have much higher peel forces. Whereas if you have what are called NFEP films, which are just FEP films with a special coating. We won't get into the technical aspects of what that stands for, but NFEP films offer less peel force. In the early days, Sol came with FEP films, but nowadays, if you buy a Sol now, for instance, you'll get it with NFEP film. If you've got a printer that has an FEP film, consider getting a new vat. If you call Ackuretta and you order a vat today, you will get a vat with NFEP film. And if you're printing in resins like splint resin and surgical guide resin, I highly recommend that you get a vat with NFEP film and that you print with NFEP film. Now, you will find YouTube videos talking to you about changing films. You will find that NFEP films are available on the market. And I have changed NFEP films myself on some of my vats, but I wouldn't suggest you do that unless you know what you're doing, because it can lead to a very expensive problem, which I'm going to show you on the next slide. Now, bear in mind, though, that even if you have NFEP film, you can choose platform sizes and print sizes and number of prints that you put on a platform on the software. You can control all of those things to reduce peel force as well. And I suggest you do. When you print several tiny little crowns, let's say you put 28 crowns for a full mouth rehabilitation on a large platform, people think they can easily get away with that. And you can many times, but you got to remember that each of those prints causes its own individual peel force. And that's almost akin to having a peel force across the entire area of your large platform. Think about printing those faster with a few crowns at a time with a smaller platform. You'll have more predictability that way, for instance. So just a clinical situation that I wanted to use as an example. Here's a situation where somebody had a perforation of their vat film and the resin leaked from the vat. Now, what you're seeing is a damaged LCD screen on an Ackuretta Sol. This one was on the Ackuretta user group, and the resin had leaked not only around the LCD screen, it also leaked into the actual printer itself. Now, that's a very, very expensive problem. Not only you can't get away just by changing that LCD screen, you actually end up in a situation where the electronics of the core of the printer itself become damaged. And all of this came by because of damaged film. And it's the reason why I don't recommend you attempt a film change unless you're an absolute expert at doing that sort of thing. So don't mess around with your vats trying to change them to NFEP film, because there are so many nuances to getting the tension of the film right. There are so many nuances to making sure that you don't damage the film itself. And if you do damage the film in some way, or if the film is damaged during printing in some way, you could get exactly what you see on this slide and end up with a very expensive problem. So you're smarter just to order new vats, and new vats are not all that expensive either. And it makes sense to get new vats, new NFEP films on those vats rather than try and change films as well. I made this video the other day, and there is volume on this video, but somewhere about the middle of this video, you will hear the click. Watch out for it. Did you hear that click? Just going to play that again. That click is what we call peel force. And it's an immense amount of force for the platform to have to detach the layer of resin that's just printed. But it was nice to just get an audio recording of what a click is actually like, and what peel force actually sounds like. And that's something that you can encounter when you're printing if you put your ear to your printer. Again, think about using smaller platforms. Think about using purpose-driven platforms because they help the film as well. Finally, the last source of potential failure is what's called a light source issue. Now, I've never heard of an Ackuretta Sol have a light source issue. The Sol has 54 matrix LEDs that are dynamically controlled by the electronics of the printer. These LEDs only light up where they need to, meaning if a certain LED that's part of that array doesn't need to light up to cure resin, it doesn't. And so that prolongs LED life. It also prolongs LCD life for that matter. Sol is an LCD printer, but it gets terrific LCD life. Most LCD printers will tell you that LCD screens last about 2,000 hours. If you use a Sol properly, you should get about 10,000 hours out of a Sol quite comfortably. And it's not anytime soon that a regular practice that is using a Sol chairside or in their in-practice lab is going to, it's not as if you're going to get to that number anytime soon. So the LED array in the Sol works pretty well, and it's unlikely that you'll get LED failures. It's also unlikely that you'll get LCD failures, but both of them are hypothetically possible. What I see more commonly, though, with light source issues is smudged film. So if you look at this picture on the left, you can see very, very smudged film, and you can see a splint resin failure with the splint sticking to the bottom of the film. And this is typically because the film of the vat has not been cleaned properly. You may occasionally need to clean your film, both on the inside and the outside. Do it very, very carefully with highly absorbent tissue, very gently, and also do it with air. Again, you can also smudge the glass screen of your LCD, and that's something else that you can clean with dry tissue very, very carefully. All of that affects the transmissibility of the light source, and that can lead to failures as well, and that's something you can look at as well. Here's something I really, really want to talk about. What do you do after a failure? It's all very nice to talk about why failures occur, but here's typically what I do after a failure occurs. So let's get to this play button here and play this. So we've had a model print with the Curo element resin fail on this printer. The Sol comes with what are called preset times for vat cleaning. And if you've got the right resin set on the printer, then you can select what's called the clean vat function. What the clean vat function does is something very, very unique. The clean vat function has a certain time duration to it that, as I said, is programmed according to the resin. If you turn on the clean vat function, it causes the LEDs of the printer to come on for the period of time that the clean vat function mode is on. And so what that does is it cures a rectangular layer of resin within the vat. And you'll see how you can take out the build platform, take the vat off the printer, and then using something non-metallic like a business card, it's very, very useful to lift up the corner of that cured rectangle of resin and then take that whole rectangle out and throw it out. What that does is it picks up all particular debris that is in the vat. Now, obviously, this is limited to the light source and the size of the light source. There are peripheral areas of the vat that are not fully covered. If you still have failures after you've done a clean vat function, then you would be smart to actually filter out your resin. How do we do that? And so if you're going to filter out resin, the smart way to do that is to actually get the resin bottle lined up. Make sure you pick the right resin bottle, of course. You pick up whatever resin is left behind in the vat, use a funnel, get a filter into the funnel, and pour the resin through the filter, through the sieve. And so, what happens here is any particular debris is filtered out by that filter. After that, you need to use a rubber spatula, easily obtained in any cooking item store, and you can clean out all the excess resin, put your bottle away, obviously seal it, and then you can clean your vat to make sure that there is no particular debris. You can use that you can do that by spraying IPA into the vat and mopping up the excess alcohol using tissues. I'm sorry, wipes. And so do that repeatedly until there's absolutely nothing left in the vat and your film is absolutely clean. I tend to follow up on the wet alcohol wipes with dry tissue in order to take out any smudges from that film, make sure it's absolutely clean. And then I'm ready to start printing again. So it's not just about having failures and figuring out why those failures occur. I hope I've given you a decent understanding of why those failures occur, but it's also important to take care of your printer after a failure has actually taken place. And that's significantly important as well if you want to make sure that your Z-axis isn't thrown out of gear and if you don't want to create further problems for yourself. Thank you very much for logging in. I hope you've enjoyed this very practical presentation. I commend Ackuretta for being willing to talk about such a topic. And I hope you've all understood a little bit more about 3D printing. And I hope you can look forward to less failures in your 3D printing journey. We're happy to take questions now. And I think Xav is going to take over and
Yes, thank you so much, Dr. Nitish. It was a great presentation. There's a lot of details, a lot of experiences that you had, and I'm sure that everybody has learned of what you have done and understood that everything goes. It's a combination of factors, and it's a comprehensive approach when you have a failure and knowing that with Acurata the quality is really good. So it's sort of easy to understand or to fix the issue readily when that happens. So now we are gonna enter the Q&A session. So as I mentioned at the very beginning, on your bottom right of your screen, you will see a questions tab. You can go there and ask your questions. We have few at the moment, so we will start with those. So starting from the very beginning, Ms. Megana says, LED not working, what are the reasons? LED, meaning what we understand LED is the LED array, is not the LCD screen. So what we would say in this case is that first contact your dealer, the person where you bought it from, or you can do a ticket with us. So then we can look into it. LED issues not working is very, very rare. If anything, it's LCDs that our LCD has a lifespan of 10,000 hours. So it wouldn't probably, it's not the LCD, not the LED, but the LCD sometimes it degrades over time if you keep using it. So please do that, and then we can move forward and we can fix your issue. Mr. Jamie Do says, are models best printed oriented flat with supports or no supports but add drainage holes?
Okay, models, it depends on whether you're a novice user or an expert user. I'm sorry to give you that kind of answer, but if you get good at it, the best way to print models is supportless with drainage holes. It's faster, it uses less resin, and that works very, very well. But if you're starting out on printing, I definitely suggest, Jamie, that you consider using supports for your models. I'm going to go to your next question as well, Jamie, because I can see it here. You bought your Acurata only a couple of months ago, and you want to know if your VATs are FEP or NFEP. Call into tech support and give them the serial number of your printer, and they probably will be able to tell you that. And if you don't have NFEP, I mean, FEP is not bad. I'm sorry if I made it sound like FEP is evil in some way. That's not true. I printed for years with FEP film, and you can certainly get successful prints with FEP film. If you're doing a lot of splints and surgical guides, however, and that kind of resin, I would recommend ordering an additional VAT with NFEP, even if you do have an FEP based VAT yourself. So that's something I'd certainly recommend that you consider. But you can call tech support and then find out um, if your VAT came with FEP or NFEP. I'm going to try and address questions from some of the other users, if you don't mind, Jamie, and if you still have time, I will come back to your other question. I've got a question here from a Dr. McKinsey. In case of filled resin failures, would the same cleaning protocol apply? Well, it depends on what you mean by filled resins. Let's take the example of a highly filled resin like patent rod and sculpture, for instance. Yes, as far as the clean vac function is concerned, it would apply. I know it's a very expensive thing to clean the vat with highly filled ceramic resins, but at the same time, if there's particular debris in the vat, that can really cause problems for you. If you want to avoid the clean vat protocol, you could consider filtering the resin if you like, but that's easier said than done with some of those highly filled resins. They're so viscous sometimes that they don't flow easily through filters as well. With some of those resins, it's best to avoid a failure in the first place, and then make sure you've got everything selected correctly, and that certainly helps things. What else have we got? Dr. Meghna says LED failure can be due to a number of reasons: cable connection, resin spill. It's best to contact your dealer support if you are sure the LED doesn't work. Absolutely. Can't emphasize that more, Meghna. Absolutely valid point there. Don't try and replace your LED matrix yourself. It's quite easy to figure out if there's an LED problem, though. You can do what's called an open exposure. Take the build platform out, take the VAT out, everything, and you can turn on the LED using the clean VAT function if you wish to, and then have a look at your LEDs if you wish to. But as Zab said, it's very, very rare. I really haven't heard of anybody with an LED failure yet with the solve, but it's possible. It's certainly possible. Now let's look at Jamie's other question. My first few prints were 2mm supports plus 0.2mm base layer. Failed. So I tried without supports and it was successful. Well, I wouldn't make a blanket statement like that. So supportless printing seems to work better with certain types of resins, and I prefer supports with certain types of resin. So I don't try and do everything supportless. If I'm doing splints, for example, I absolutely want supports. I'm never going to try supportless sprints for any reason. And so with regard to 2mm supports and a 0.2mm base layer, if you're selecting a resin profile in AI Premium, you shouldn't have to meddle with those things, Jamie. And you are suggesting that you've just started out on printing. I don't know how much of a user you are. You may be an expert user who's just acquired the solve. But if you're not, then I suggest staying with the AI Premium and with getting the software to do the support generation and the base layer thickness generation for you. But yes, it's possible. Base layer thicknesses can be too thin or too thick sometimes. Both of those can cause failures as well if you really want to get technical for various reasons. And yes, support thickness does matter depending on what you've got, what you're printing. At least in the earlier days, when we used to do all of this manually, we did see more failures. You should be seeing less failures with AI Premium. Yeah, I think we've got all of those questions, Zav. I don't see anything else unless somebody has asked for any questions in the chat itself. No, I don't see any questions.
There was one question from Jamie as well. He asked if there's any benefit to roughening the surface of the platforms for better adhesion, or anodized out of the box is adequate. The thing here, it's not about the anodization. The anodization is to protect the build platform. The key ingredient here is the hairline. The hairline is the one that increases the surface area, so it's easier to stick. That is the key part. Now, once it comes out of the box, we already made it in a way that you don't really have to roughen it up from the beginning. After many prints, you will notice that it won't be so rough. So then eventually it will be advisable to do it, but it's going to take a very long time until you have to.
Yeah. Let's talk about the risk of doing that, though, Zab, because I'm not entirely in favor of picking up sandpaper and starting to abrade these platforms. We used to do that with some of the aluminum platforms that came by in the past. But the problem with those platforms became that when you do ceramic resins, for instance, ceramic resins contain ceramic filler particles. Now, these filler particles, strangely enough, abrade metal. They're abrasive enough to abrade metal. And they used to abrade the aluminium of the platform, and that used to leach aluminium into the resin in the vat, leading to a discoloration of the resin. And that's what anodization addresses. So, anodization basically makes sure that your platform is abrasion resistant. But in the process of anodization, you can lay that down as a smooth layer, or you can lay that down as a rough layer. Ackuretta chooses to lay that down as a rough layer with a hairline thickness. And so that's what the company refers to as hairline anodization. If you're going to pick up sandpaper and start to abrade your platform, you can take away that hairline anodization. Indeed, you can take away the anodization itself. And so I honestly would say that if you get to the point many hours of printing later where you find that your prints are failing because of a lack of adhesion, just get yourself a new build platform. I don't think you should be picking up sandpaper even at that point. Would you agree with me, Zeb?
Yes, I do. I do. Absolutely. I agree with you. Again, it's going to take a long time until you really need to sand it at all. And yeah, it's very resistant. So it really takes a very long time.
Yep.
Okay, wonderful. Let's see if there's any more questions. Okay, I believe, yes, there is one more question for Dr. Nitish. He says, Mr. Chris Rajan says, "Hi, Dr. Nitish. Wonderful presentation as always. Let us know your experience with printing ceramic crowns and direct aligners such as graphy, resin using Ackuretta interface."
Right. Great question, Chris, because you're right at the cutting edge, obviously. I do print in packed rodin sculpture, and it's the only ceramic filled resin as of this moment that is validated for the sol. Am I right there, Zed? I can't think of anything else.
Yep, that's the one that we also recommend the most.
Yeah.
It's very good.
So at the moment, that's the only ceramic fill product that you can print with the saw. And so it's a very predictable resin for printing ceramic crowns. Now, am I somebody who is absolutely sure that printing ceramic fill, because your question says printing ceramic crowns. Let's be a little clearer on that. It's printing ceramic filled resin crowns. Okay. So you don't get pure ceramic crowns, you get ceramic fillers in resin. The filler content is approximately over 50%, and that's got to do with requirements in the United States with regard to insurance coding and all of that stuff that manufacturers are absolutely very keen to meet. But I print a lot of ceramic crowns. Am I sure that these are definitive crowns? I think the jury is still out there on that one. But yes, I do print ceramic crowns. Great experience so far. They are very good long-term temporary restorations, if not definitive restorations. But I'll hold my opinion until I see how my crowns perform long term before I actually say anything. At the moment, I'm using rodin sculpture for crowns, and I'm also using rodin sculpture for full arch implant prosthesis, and it works very well for that. Now let's come to Graphy direct aligner printing. Graphy is a Korean company, and they fabricate a resin that is supposed to help to print aligners directly. It's not by thermoforming, which is the conventional technology used to manufacture aligners. Graphy is saying you can print an aligner directly in their resin. So there's no suck down model, there's no thermoforming involved. Again, I'm not sure. First of all, let me say that Graphy is not validated for the Ackuretta Sol yet. I'll be careful when I say this. I know it's a process that's underway. I know that the option is being explored, but I know it's not there yet as well. And so at this particular point in time, the easy answer to your question is no, because the resin is not validated for the printer. My own opinion on direct aligner resins: there are some top orthodontists in the world that are using direct aligner prints for orthodontic treatment. There are top orthodontists like Kenji Ojima, for instance, that are out there. Ravi Nanda, for instance, was recently speaking about the graphy resin as well. So is there potential? Absolutely. I think that is the future. Do I think that that is there yet? I really shouldn't answer that question because I don't have any experience with the resin yet. I've seen it, I've seen the aligners, they look promising, but I can't tell you if I can't tell you from personal experience whether it's something you should be doing yet. I hope that answers the question.
Yes, and that's completely right. We are working with Graphy since a while back already to validate those resins with our system. However, what happens is that the resin is can be a bit temperamental, can be a little bit difficult to work with. Sometimes you really need to do it very well, and because it has so many requirements, we want to make sure that when we are validating it, we are completely sure that everything is going to be okay. So that's why it's taking a little bit longer than usual, but eventually within a month, maybe 2 months, it's gonna be out already in our system.
Yeah. Bear in mind as well that the Sol is hardware and Accurata is a resin manufacturer and a hardware manufacturer. As a hardware manufacturer, they are continually adapting to the market as well. There are new resins coming out every day that require different things, you know. So, for example, is the Sol going to be the last printer that Accurata makes? I don't think so. As newer and newer materials come out into the market, the 3D printing market will adapt, and so will Accurata, like any other printer manufacturer. At the moment, though, the Sol serves beautifully for a whole spectrum of resins that are available on the market. Now, the other thing that, for example, is post processing as well. It's not just about printing, isn't it? It's also about post processing, and so Accurata is bringing out the Curie Plus, for instance, in May, which is nitrogen inhibited curing. The beauty is, though, that in the past, I've been curing with nitrogen inhibition for, I don't know, for quite a while now, for about 3 years now. And I have a large nitrogen cylinder outside my practice, and it supplies a nitrogen curing unit. The beauty with the Sols, with the Accurata curing unit, is that it's going to come with a nitrogen generator, which means it's going to make nitrogen out of atmospheric air and then supply that nitrogen into the curing chamber. Now, when you have such good post-processing protocols, it again opens up the printer to a whole bunch of other resins that could potentially be used, because you get even better physical properties on some of those resins. So watch this space. The resin market is continually expanding, and the hardware manufacturers will continually either expand their portfolio or improve on their offering to continue to meet the demands of new resins.
Yes, I think that was a very good answer, very comprehensive on all the details and everything. That's why we're so happy to have you for this lecture. I believe that we do not have any more questions anymore. So now we will proceed to announce the winner of the 1 year free trial for the Alpha AI, and we are gonna give it to Dr. Yu Ishikawa-san. I repeat the name just in case. It's Dr. Yu Ishikawa-san. So congratulations to you, and thank you so much for everybody for being here, for making the time. Thank you so much to Dr. Nitish as well for taking the time and explaining so well all his experiences and reducing the failures for the printing process. That I'm sure that everybody will be grateful. We will be posting this webinar in our YouTube channel in a few weeks. So please stay tuned. You will see it in our newsletter that will be sent. So thank you so much for your time. Again, Dr. Nitish, thank you so much for your time. Very, very interesting presentation.
Thank you. I hope you've bought a Sol. You lives in southern New Zealand, in South Island, in a town called Alexandra, and runs a very, very successful practice. I hope you can pipe in and tell us whether you've got us all to use the software for. But in any case, congratulations. That's a great gift to win. You just saved yourself a couple of $100 in subscription for the AI premium license. So that's cool.
Wonderful. Okay. So thank you so much, everybody, again, and see you next time.
Thank you.
Thank you.